Welcome to Manifested Publishers.
Welcome learners, my name is Stephen Kariungi and we continue with our topic of discussion, and we are discussing reaction rates and reversible reactions. And at this stage we are investigating the effect of a catalyst on the rate of chemical reaction. And in our previous lesson we used a demonstration on how hydrogen peroxide decomposes to produce oxygen gas in the presence of a catalyst and also in the absence of a catalyst, whereby we saw that in the presence of a catalyst, which was manganese 4 oxide, the rate of reaction was faster. So more oxygen was obtained within a shorter time. But where there was no catalyst, the hydrogen peroxide still decomposed, but at a slower rate, and therefore there was less oxygen being produced per a given time. So we are going to have a graphical representation of the effect of a catalyst on the decomposition of hydrogen peroxide. So we're going to have a curve So here we have the volume of oxygen produced, and we have the time. In seconds. So the first curve is in the presence of a catalyst, and the second curve is without a catalyst. So you can just change it a bit and say with a catalyst and without a catalyst. And then without a catalyst. From that curve, we find that with a catalyst, we collected volume T of oxygen within time 1. That's a very short time, which is a very short time. And that's why the curve is very steep. So the gradient of the curve is very steep in the presence of a catalyst. However, in the absence of the catalyst, it took a very long time, which is time 2, to collect the same volume, which is volume T. So that shows that the graph without the catalyst is very gentle. It has a very, low steepness, or it's less steep. So we can say that in the presence of the catalyst of the manganese 4 oxide catalyst, the rate of decomposition of hydrogen peroxide to produce oxygen was faster. And you can say that this is because the catalyst provides a surface for the reaction to take place. The mass of manganese 4 oxide remained the same. The mass of manganese 4 oxide remained the same at the end of the experiment. That is chemically unchanged. It remains chemically unchanged. So the catalyst provides a surface for the reaction to take place, but it does not change chemically. So it remains chemically unchanged, as can be witnessed by the mass of the catalyst remaining the same. So we are saying that with the catalyst, the time taken was shorter. That is T1. Also, the total volume of oxygen produced was the same. As can be seen from the graph. That is volume T, which is volume total. So the time taken for volume T to be produced with the catalyst was T1, and without the catalyst was T2. So we can also say that a catalyst speeds up the rate of reaction by reducing the activation energy, as shown below. So we reduce the activation energy so we have the reactants, the products. So we can show this. So that is activation energy without the catalyst. And the next one here is EA with the catalyst. In the presence of a catalyst. So with the catalyst, the EA is smaller. But without the catalyst, the EA, or the activation energy, was higher. So these are the reactants, and these are the products. This is the reaction path, and this is the energy. So the graph here shows that the catalyst speeds up the reaction by lowering the activation energy. So that's why with the catalyst, the activation energy is less. But without the catalyst, the EA energy is higher. So activation energy 1, activation energy 2. So other catalysts, so you can have other catalysts used in industrial processes include, so we have the catalyst, then we have the industrial process. So we use finely divided iron as the catalyst in the Haber process for manufacture of ammonia. Then we use vanadium 5 oxide or platinum in the contact process. And then we use platinum rhodium catalyst in the Ostward's process. The Ostward's process is the one that manufactures nitric 5 acid. Contact process manufactures sulfuric 6 acid. Haber process manufactures ammonia. So this is for ammonia. This is for sulfuric 6 acid, and this is for nitric acid. So in each of those reactions, we use different catalysts. So the assignment So the assignment 1A, what is the effect of a catalyst on the rate of reaction and on activation energy? And B, name the catalyst used in 1, Haber process, and 2, Ostward process. So we'll stop there. Until next time, goodbye.